Welcome to Teja Statistics. In this class, we are going to discuss about the data science first year statistics. Uh, Effect of change of origin and scale on movements, which we have to learn. Okay, very important. So, by the way, what is changing of origin and what is changing of scale? So, let's see. Central movements are independent of change of origin, but not the scale. Let ui be the another variable. Okay, let x be the first previous variable. So we are subtracting from that x variable is a constant a, and we are changing the origin, that x variable origin we are changing. Next, coming to the uh, scale change. So what is change of the scale? So multiplication or a division of that variable. So we are dividing with one uh, constant called h. Okay, so here we get a new variable xi minus a divided by h. A and h are the constants, and xi the variable, and the new variable will be our ui. So we are letting that one, and xi is equals to ui into h plus a, put as equation number 1. Next, so what is x bar here? X bar we are trying to calculate, that is x bar is equals to, so u bar into h plus a, put it as equation number 2. Now do the subtraction of these two, 1 minus 2, or 1 and 2. Okay, so x minus x bar is equals to, if you common that h value, you will get the value of ui minus u bar. Okay, and that will be our uh, equation number 3, or we can say it as a star. Now we know that, so mu r formula, mu r is equals to 1 divided by capital N summation I runs from 1 to n fi into x minus x bar whole to the power of r. In that from star, in place of x minus x bar, we have to substitute the h into ui minus u bar whole to the power of r. So now keep on multiplying with h to the power of r and ui minus u bar whole to the power of r. So here the h to the power of r and 1 by n, summation I runs from 1 to n fi into ui minus u bar whole to the power of r. So here we got the independent from changing of origin. That means we are not getting any constant value of a, but here we got the h to the power of r in the numerator. So then we can say that it is a not independent from the changing of origin, but not scale. Okay, scale, because it is independent from changing of origin but not the scale. So independent of origin but not scale means, so we are not getting any origin values, we are getting only the constant h values, so they are said to be the scales. Okay, so very important. Next, case 2, or non-central movements also we had to do. In non-central movements uh, are independent of change of origin but not scale. Again we have to use the same formula. Let ui is equals to xi minus a divided by h. Xi is equals to ui into h plus a, put it as equation 1, and x bar is equals to u bar into h, and constant a will get the same. Next, subtract 1 minus 2, and x minus x bar is equals to, here we got ui into ui minus u bar of h put as star. Now we know that the non-central movements formula, that is what is non-central movement formula, that is here 1 divided by capital N summation fi runs from 1 to n fi into xi minus a all to the power of r. So from here xi is equals to mu I into h or ui into h. So what is xi minus a? Ui into h. So ui into h, we substitute xi minus a all to the power of r. So here we got that ui to the power of r into h to the power of r. So this is in the formula of h to the power of r, 1 divided by capital N summation I runs from 1 to n fi into ui to the power of r. So here the non-central movements are also uh, independent of origin but not the scale, hence it is proved. Next, Shepherd corrections. What is this Shepherd corrections? While calculating the central movements uh, for the continuous frequency data, we are converting the class intervals into the frequencies that time, so we may get some error values. Okay, to remove that error values while calculating the central movements for the continuous frequency data, that time we had to use these Shepherd corrections. So calculation of movements in a continuous series are based upon the assumption that all the values of any class are concentrated around the midpoints. This assumption is generally true for symmetrical distribution, even moderately skewed, in which the class intervals not greater than 1 divided by 20th of the range, okay, of the distribution. These assumptions leads to the systematic or symmetric error uh, in the even movements. So mu2 is corrected by, so mu2 can be corrected by mu2 minus and mu2 uncorrected minus h square divided by 2. What is h here? That h is our class width. Next, what is about mu4? Mu4 uncorrected or corrected is equals to uncorrected minus h square divided by 2 into mu2 plus 7 divided by 2, 240 h to the power of 4. So where h is the length of the class interval, okay? By calculating them, we will get the values, exact correct values, okay, of the given movements for and courtesies for. So here we have to use the Shepherd corrections for continuous frequency data while calculating. Next, the beta 1 and beta 2, mu3 square divided by mu2 cube, and beta 2 is equals to mu4 divided by mu2 square. Okay, gamma coefficients, gamma equals to under root of beta 1, gamma 2 is equals to the movements. Next we have to see the beta 1 is the calculation of the skewness, that is mu3 square divided by mu2 cube, where beta 1 is always greater than 0. Next, coming to the beta 2, that is mu4 divided by mu2 square. So the gamma values, gamma 1 is equals to beta 1 under root. Next, gamma 2 is equals to beta 2 minus 3. Okay. So these are some problems we have to see. Okay, the first four movements of the distribution about the values 4 of the variable are as follows: mu1 dash, mu2 dash, mu3 dash, mu4 dash. 1, 4, 10, 45 they given. Find out the mean of the distribution and calculate the central movements also: beta 1, beta 2, gamma 1, gamma 2. So mean is equals to x bar is equals to xi minus a. Okay, x bar is equals to a plus mu1 dash. So x bar is equals to a plus mu1 dash is the formula. So what is a plus mu1 dash? So here we can say that is equals to 4 plus 1, that is x bar equals to 5. Now the central movements: mu1 is 0, mu0 is 1. Okay, mu2 is equals to mu2 dash minus mu1 dash whole square, that is 4 minus 1 square, that is 4 minus 1, that is 3. Next, coming to the mu2, we got here is 3, and mu3 is equals to mu3 dash minus 3 into mu1 dash, mu2 dash into mu1 dash plus 2 into mu1 dash whole to the power of 3. So like that we got here is the 10 minus 3 into 4 plus 2, 1 to the power of 3, we got 0. Coming to the mu4 value, if I substituted, then we got the values as 45 minus 4 into 10 of 1 plus 6 into 4 of 1 square minus 3 into 1 to the power of 4, that is we got 26. Thank you.